Hey, here's a video that I wanted to go through another integration by parts problem. The problem's a little more difficult, but not much. Still can use the same method. So here we go. I think in this case, if you've been practicing, well, first of all, you should probably pause the video and try to give this a shot yourself. But here we go. I think it makes sense to let u be equal to x and let dv be equal to secant squared x dx. Once we pick that, we're locked in. Du is equal to dx, and v, you should remember at this point, the backwards derivative of secant squared is nothing more than good old tan x. So this turns into this now. This turns into u times v, which is just x times tan x minus the integral of v du, tan x dx. Okay, now you might be thinking that tan x is difficult to integrate, but it really isn't that bad. Let's go off to the side. Let's just go over here and do tan x. So if we were just going to take the antiderivative of tan x dx, what I would do is I would write this as sine x over cosine x dx, and recognize that this is ripe for a u substitution because sine is the derivative of cosine, vice versa, maybe with or without a negative. So if we do it this way, if we say let u be equal to cosine x, then we are locked in to du is equal to negative sine x dx. So to do my u substitution, I got sine x dx here, that's going to become du, but I need it to be negative, so I need to tack a negative on out front. So this is going to become negative integral of 1 over u du. And we know what that is. That's going to be negative natural log of x. Now, I'm putting absolute value bars around this because I want you to get used to this idea. It's going to come up later when we do differential equations, why we have to have that. So right now, I know we're used to saying, rather flippantly, we're used to saying that the antiderivative of 1 over u du is, that should be a u, is the natural log of u. And I never really mentioned the absolute value bars before, but soon we're going to get into differential equations. Just a good habit to get into, and I'll explain why at that point. But for now, let's put all of this, let's change it back to x first. This is really the natural log of the absolute value of cosine x. Okay, so now let's take all of this and put it back in for that. So now what we have is x tan x minus the negative natural log of the absolute value of cosine x, and always plus constant. So in the end, final answer to this question is simply x tan x plus natural log absolute value cosine x plus constant. And if you differentiate that, I think you'll find that you're going to end up with that. Okay, so this is, this one's a decent one. It's on the harder, I don't say it's too hard, but I came across it in a textbook somewhere, so here it is, another example of integration by parts. I'll probably end up putting a few more up before we move on. All right, take care.